In this video, we're going to start assembling the parts of the tower and arm onto the robot chassis. You can see from the instructions, we need to take our tower side here and attach it to, it looks like the 7th hole in, 2 from this slot. Now we don't have the motor on it yet. We'll put it on after we attach it to the robot. So back in Autodesk Inventor, I have the base. I need to bring in the assembly I made for the tower right side. Remember, calling that right as we look at it from the back. You can tell from the preview that is the correct one. So we're going to open this, place it somewhere near where we need to be. Okay. Double checking the picture. The C channel needs to be so that the C is facing to the outside. So let's go back. I'm just going to free rotate this just a little bit. You don't have to, it just makes it easier to get to the part I want. Now, you may notice a problem. This component does not have any eye mates. While the C channel had tons of eye mates when I made it, when you save the assembly and then bring that into another assembly as a sub-assembly, you don't have any eye mates unless you added them to your assembly file. It does not inherit eye mates from the individual parts. So we have 3 options. We could go back to the assembly and add the eye mates in, but to do so we'd have to create a couple of temporary structures. We could delete this assembly and just assemble the parts onto the robot. You can do that if you don't like the next method. But I'm going to show you how to assemble without using the eye mates. It's very useful to know how to do because most parts don't have eye mates unless someone bothered to place them there, and sometimes you need to do things where there aren't eye mates. Basically, I'm going to use a set of 3 constraints to do the same thing that 2 eye mates would have done. And it kind of makes sense to do it this way. It's almost how you would assemble it when you were putting it together. If I were to try to fit this C channel into this U channel, I would line up the edges. I'd put this face of the metal against the inside face of the U channel. I'd slide it down in place till it hit the bottom, and then I'd adjust it till the holes lined up. That's what we're going to do with constraints. So the first one I'm going to do, on the assemble ribbon, I'm going to go to the constraint menu. I'm just going to use a mate constraint. I'm going to zoom in and I'm going to pick this flat surface. You can see the unit vector facing off of it. It's a normal vector. I'm going to click that for my one selection. Then I am going to rotate my view a little bit and I'm going to pick the inside edge. Now, it helps to click where you want the part to be, or at least near, because it will match up the 2 places that I clicked wherever they are. And it just helps if it brings the parts close in. I'm going to apply that. Actually, I'm going to click OK first so I can show you what happened. Now, I can move this part around, but it is attached to that front edge. Now, the next thing I need to do is line up the holes. Now, these are square holes, so I need to line up 2 sides of these square holes. Let me adjust my angle so I can see which holes I need. Remember, I need the 7th set of holes, so I need these to line up. Zoom in, constrain. Now I'm going to leave it on the mate constraint, but I'm going to switch it to a flush so that the surfaces basically line up. I'm going to do it with this flat edge of hole number 2 and this flat edge here. Now it jumped it over here. I wasn't on the exact hole I needed, but it lined it up. They're flush. If I click OK, you can see now this moves from side to side in the channel, but it can't move up and down. So I get it into the proper place, and all I have to do is zoom in and make sure that this edge and this edge are flush. So constraint, change to a flush constraint. That plane, that plane. That is now locked in just as good as it would be as if I'd used 2 insert eye mates. At this point, I need to place a V5 smart motor. You can go to the motors submenu and pull in a smart motor. Okay. Now, I do have iMates on the motor, but because I used a subassembly, I don't have iMates on the tower. Well, that's actually not too bad. We can get around it the same way we did the tower side. If you were to put a motor on the robot, you would probably line the holes up as close as you could get them, and then push the motor onto the C channel until the edge is flush. We're going to do that. Okay, I do have cylindrical surfaces here on the bearing flat. So I'm going to go to constraint. I'm going to leave it on a mate solution, and I'm going to pick the rounded edge of that motor. Let me zoom in so it's a little clearer. The rounded edge of the motor. You can see the dotted axis going through it. I'm going to click that, select it. Now that lines up with this. The third hole down, the third one on the motor. I'm just going to mount it to here. Now, by default, it chose this solution right here that has the motor facing this way. I want to be certain that I pick either the aligned or the undirected. Right, the aligned is the one I want. It flips it this way. Undirected would let me pick either one later depending upon other constraints. But if I pick this one, it puts the motor in the right direction that I need. Now I can pull the motor in or out, and I need to line up a second bolt hole. Okay. Constrain. Just go ahead and pick. Now, let me show you on this side. Here's where the motor shaft will go. This is the one we already used. We're going to pick this one, and I'm going to line it up with the next hole. Rotates the motor in place. The motor now can only go forward and backwards. It can't rotate. One last constraint. Constrain. And you need that motor pushed until this edge of the plastic meets up with this inside surface. That motor cannot go anywhere. It is now fully constrained. Okay. We also need a drive shaft. So go to the motion folder. Believe it is a 4-inch drive shaft on here. And we're going to need a metal shaft collar. Might as well pull that out right now too. Okay. Now there never were iMates on our shafts. We're going to constrain them with an insert constraint. And I'm going to constrain it to this side of the bearing flat. I believe we want to insert that about 1 inch. Let me take a look, see if that's far enough in. I believe it is. Yeah, it looks good. We'll apply that. If we want to line it up with the motor, because right now it rotates, we need that angle constraint. Now it can't rotate. You recall we made the motor flexible. I can't see flexible on here because I still have the shaft selected. Even though I am over the motor when I'm right clicking, I need to click off. I need to select the motor first and right click. Make the motor flexible so that they rotate. Shaft collar. Again, it would be easy to put it to an iMate on the inside of here. We don't have one. So, use other constraints. I'm just going to insert, I'm going to pick the center line. Right there I can see I have the center line. I'm going to line it up with a circular component here. You could zoom in, pick the edge of that bearing flat if you could see it. I can also pick this. It's on the same axis. That'll work. Click OK. I'm going to pull it out. I need a mate constraint, just a surface mate constraint. I need this edge of the metal mated to this edge. I'm going to apply it. I need to line up the angle constraint to lock that in place. If I zoom in, I see that there. And I'll just mate it to any one of these surfaces on the drive axle. Take a look at our view. there we go. Axle's in place, it rotates, it's got a lock collar there to keep it from coming off. Looking back at the instructions, we just need to add the components for the bolt and the nut to help hold that tower piece in place. We are going to need to place a 7/8 inch spacer for between the C channel. We are also going to need to place a few structural components. We will need 2 one-post hex nut retainers. I'm only going to bring 1 in for now. We're going to need a nut and an 1.5 inch bolt. Open those, place those up here out of the way. Now, our component has no eye mates, but the U channel does. We can still use those. Going to zoom in, bring this into place. Snap that into place. Get the other end. Let's bring the nut down. Lots of eye mates overlapping here. Oh, that was the, nope. There it is. Rotate a little bit so I can get the angle I need. Add the angle constraint, that locks the nut in place. Okay, I'm going to go to the back side. I'm going to copy out one of those retaining. Alright, so let's see. Goes right there. Zoom in some more, get rid of all the extraneous eye mates. There we go. Need my bolt. Okay, now I know I don't have the spacer in place yet, but it really doesn't matter what order I do that in. Got lucky, found the right eye mate there without zooming in. Change to this angle, get rid of those eye mates. Now I need to get the spacer over there. If I had eye mates, it would be a really fast one eye mate connection. As it is, it's not difficult. 2 constraints, center line to center line. Line it up on the bolt. Apply it. Now all I need is a mate constraint. I need this edge to that edge. I didn't even have to rotate my view. Locked in place. It spins, but it's a spacer, it's allowed to. Bring us back to the home view, and in the next video we're going to start to add the gear at the top and put the arm pieces on.